So we've got two vectors here, AC and AB, and we're asked to find the cos of an angle that relates to them. Well, I think the only way to understand entirely what's going on here is to set up a diagram. So I've popped on our two vectors, AC and AB, and I've also put on this green square because what we've got to do is going to have to find the length of all these three lines, the yellow, the red and the white, using Pythagoras and these horizontal and vertical distances to find the length of the lines and therefore get this angle here in terms of the cosine rule. Let's start with the yellow line here, a vertical of 1 and a horizontal of 2. So I can say that AC, the modulus of AC, the length of AC in other words, is the square root of 1 squared plus 2 squared, which is equal to the square root of 5. Okay, now the red line, this one here, this is AB, is equal to the square root of, it's 4 and 1, so this is 1 squared again, plus 4 squared, which is the square root of 17. Now the white line, and this is the square root of, and it's 1 and 3 here, so this is 1 squared plus 3 squared. And this is equal to the square root of 10. So we're going to have to use the quadratic formula. Let's write it out. As we're going to have to find this angle, I like to move the formula around rather than substitute in and then move the numbers around. So do BC, cos A, is equal to B squared plus C squared minus A squared, and therefore cos A is equal to B squared plus C squared minus A squared all over 2BC. Now, if this is the angle we need, this must be effectively A. And the other two really don't matter, but let's make that one B and that one C. So this is equal to 5 plus 10 minus 17 all over 2 multiplied by B and C, which is root 5, root 10. Remember, we're just finding the value of cos A rather than A, so we don't need to resort to a calculator. We're not allowed to in this paper, so this should still be simplifiable to something that looks quite nice. 5 plus 10 is 15, take away 17, so we've got negative 2 on the top, all over 2 root 5, and I'm going to split the root 10 into root 2 root 5, and now we can cancel. The 2's cancel, and the 2 root 5's go to 5. So what are we left with? We're left with 1 on the top over 5 root 2. Oh, this should be negative 1, because this was a negative 2. And that's the answer. Yes, you could rationalise the denominator if you want, but they won't avoid giving you full marks for that answer.